speaker for the series, for the research colloquium series, Dr. Frank Russo. He is the Hear the World Research Chair, fancy as is, professor of psychology and director of the SMART Lab at the Ryerson University. He's also a member of the communications team and founding director of Singing with Parkinson's. He also is a fellow of the Canadian Psychological Association. His research investigates the biological, cognitive, and social basis of music and vocal facial communication. Applications of his work include music-based programs and technologies that may support the social well-being of people living with communication difficulties. Let's welcome Frank.
Thank you for the introduction, Yana. So I am going to talk about singing, but the focus really will be on communication more than singing. So what I'll attempt to do is provide a scaffolding by talking about some of the basic science of singing, and then I'll talk about some interesting applications for communication that our group has been involved with. So, some tenets to begin with. I think that singing is evolutionarily very, very old. I really see no other option than some sort of early communication being sing-song-like. You know, I think before we had cultures that allowed for a lexicon to develop, we must have had some sort of multimodal communication that involved intonation patterns that are not that different from the way we think about singing today. So I'm not arguing, by the way, that singing is older than speech or the other way around. What I'm saying is that early communication probably had a lot of similarities with singing. So it's not at all arbitrary to be thinking about singing as a way to deal with modern communication. Okay, it's not like this is some other species entirely. Singing is obviously rhythmic, so it's not rhythmic in the way that dance music is rhythmic. You know, but clearly there's a pulse that keeps going, and we're locked into that pulse, and that allows groups to sing with one another. So we're going to explore that a little bit. It tends to be emotional, so we can sing for aesthetic reasons, even intellectual ones that are divorced from emotion. But by and large, people feel something when they're singing or when they're perceiving song, and I think that's an important piece here. It tends to be social. It's either done in groups or it reinforces group identities, and it tends to be pleasurable. So these are some key ingredients about singing that I think are relevant to our understanding of how singing can support communication. So I really, what I want to clarify from the beginning is I don't want to put singing on a pedestal. So I do think singing is great, and we should explore its efficacy for communication, but I really don't see it as a panacea. And I think that people want us to do this. People who are interested in singing would very much like researchers to say, look, singing will help everything under the sun. And unfortunately, there are researchers that will tell you that singing will help everything. And I think there's a real risk there. We risk weakening the claims that we can make from a scientific perspective. So I'm just going to give you an example of where singing failed from a kind of intervention perspective. And this was a very unique opportunity. This is Tim Falconer. He wrote a successful popular press book a couple of years ago tracking his attempt to teach himself to sing. And I was very lucky because Tim came and visited my lab. He visited a few labs doing work in the cognitive neuroscience of music to find out about tone deafness. And when he visited my lab, I said, well, you're not going away. We're doing something together. If you are actually interested in learning to sing and tracking your singing, then we have to do a few things. We have to We have to get some baseline measures. We have to see how you do as you progress. We'd like to image your brain. We'd like to do some other electrophysiological tests. And he was very cooperative, and some of this made it into his book. It was a very unique experience for me. But the short story is that Tim spent 18 months learning to sing with one of the best vocalists in Canada, and he failed to learn to sing. He could not teach himself to sing. So what you're looking at, and he's okay with my saying this, like I don't think I'm breaking any ethical bounds here. On the graph on the left, there's an interval matching task, and you can see that over the course of the 18 months, he gets a little worse, he gets a little better, he gets worse again. There's no systematic improvement. The one area where we were able to track a wee bit of improvement is on his ability to sing the song Happy Birthday. And this is only because he rehearsed Happy Birthday nonstop, and he memorized the pitch changes, and it's a very unusual way to learn how to sing. So I don't know if I said this clearly enough at the beginning. The unique thing about Tim is he is tone deaf, and there are a few individuals that are tone deaf. Many of you in the audience might think you're tone deaf. So I think there's about 50 people here, so it's possible that one of you is tone deaf, but the percentages are about 3% in the typical population when there have been surveys of undergraduates, large surveys done. So there seems to be some unique things about the tone deaf brain, and one of the most prominent features is that the arcuate fasciculus that connects sensory areas with motor planning areas seems to be a bit thinner. And what you can see is Tim's arcuate fasciculus in red, and the normal arcuate fasciculus in blue. And you can see that after all this training, he doesn't regain the size, if you like, of the neurotypical individual. So that's a lot of words to say that there are some limitations here, and singing might help some folks. It's not going to help everyone, and I could take this in different directions. There are people who are just afraid of singing publicly, and that's going to be a limitation for any kind of therapeutic application of singing. I think most of us can get over it. Most of us who think that we can't sing are probably just poor pitch singers, but there are some hard limits. All right. So what's involved in singing? I'm going to talk about periodicity. Periodicity is a very important aspect here. I mentioned the pulse, that there's a beat that's implicit in music. There's also periodicity at a very short time scale. So if we look at the repetition rate in the tones that people are singing, there's a very precise control of that aspect of periodicity. So we have periodicity at the micro time scale and at the macro time scale that need to be controlled. Those are features I want to drill down on. There's also auditory motor coupling. So we're not just putting all this periodicity out, we're developing the motor plan, monitoring input, modifying the motor plan. All that's happening dynamically. I'm also going to talk a little bit about the scientific evidence for social effects of singing in groups. And then I'll move on to applications. All right, so I've alluded to this a few times already, but I have a nice little animation here to reinforce it. Singing involves periodicity. There's periodicity at the micro time scale or fast periodicity, and what I'm talking about is the repetition rate of tones. So if you zoom in on a waveform, of course, we know that we can see the periodicity. There's also periodicity that is slow, and this is at the level of what we would call the beat or the pulse in the music. The unique thing about music is that these two kinds of periodicity are bundled up together, and we have to control these things simultaneously. So it's not like there isn't periodicity control in speech. It's not like there isn't a pulse in speech, but the level of precision in singing is unique. I really think of it as a kind of super stimulus. It's speech's super stimulus counterpart. Now, speech has its unique and special features as well. There's these rapid spectral-temporal changes that don't tend to happen in music. But when it comes to the dimensions of tight coupling of periodicity at the micro and macro time scale, singing is unrivaled. So if we want to train these aspects of speech, then I think singing provides a unique model. So here's a schematic model of what is happening when we sing. So as I said, there's obviously motor planning. Often there's reference to long-term memory. We're not just singing along with a keyboard accompaniment. We can do that, and we can all, more or less all do that intuitively, reasonably well. But often we've learned a song, and we're accompanied, and we execute the motor program. We monitor our own feedback. We monitor what's going on in other singers, and we update the motor program. So when our voice goes a little bit flat or goes a little bit sharp, we make these rapid adjustments. And it's really, I think it's really quite remarkable. Like, you can train to do this and you can get better at it, but young children can do this. By and large, all of us can do this with the exception of people that are tone deaf. There's some inbuilt machinery that allows for this tight auditory motor coupling. All right, so there's synchronization across individuals that happens when we sing. So I mentioned that the auditory motor coupling doesn't just pay attention to your own voice, you're also paying attention to the voices around you. So we can think of that as a kind of synchronization. It's a synchronization of motor activity. It's not just vocal motor or laryngeal synchronization, it's also synchronization of facial and head movements. So I'm not going to unpack this aspect of research, but my group and other groups have done some very controlled work looking at the amount of head movements and the amount of facial movement that tends to accompany pitch intervals of different size. And it's not at all random. Like, yes, there's individual expression in the way different singers will perform, but there's a lawfulness to the amount of head movement that accompanies a small pitch change or a big pitch change. Okay, so you can imagine now if it's not just the laryngeal muscles that are all synchronized, but it's also our orofacial muscles and our head movements that are all synchronized. This is an incredible amount of synchronization that's happening across individuals. So if we think that synchronization has some sort of social good, singing seems to be a great way to do it. There's also evidence that when people sing together, their respiratory patterns align, and that's not surprising. There's phrasing that's tied to the breath, so we tend to take a breath before the phrase, and we run out of pressure, and then we take another breath, and then the next phrase starts. So it's not surprising that over time, a group's respiratory patterns will synchronize. And if you sing for long enough, there's something else that synchronizes. There's also synchrony of the autonomic nervous system. So if there's emotional intent in the song, and we're working to sing something that conveys sadness or happiness, then we're all going to start to feel that together. So I hope I've convinced you there's a remarkable level of synchronization. We can see synchronization in many human activities, in rowing together, in walking together, in marching together, certainly in dancing together. I think, I don't want to create a hierarchy. I think singing and dance are great opportunities for group synchronization, but I think you'll agree that we have a unique opportunity here with singing. So how does all this happen? I could drill down on various aspects, and I'm kind of cherry picking here, but one of the neat things that auditory neuroscience has uncovered over the last decade is that there's entrainment that's taking place at the level of the beat. So if we tap our foot along to what it is that people are singing, or we sway our bodies, as we tend to do as people are singing, there's synchronization in the auditory cortex. That part maybe is not surprising, because we've got this regular pulse, and if cells are responding to that regular pulse, there should be a synchronization between the auditory cortex and what exists in the stimulus. What's more remarkable is that there's a synchronization in the motor cortex. Okay, so you get motor areas, motor planning areas in particular, that are also synchronized to the beat. Okay, and this of course provides some interesting opportunities for rehabilitation. What I'm showing you is work from Laurel Trainer's group at McMaster. There have been many studies, including work from my own group, on this sort of phenomenon, but I think this is really a nice schematic depiction here. What you're seeing is the pulse, or the music depicted with the red arrows, and you have a faster pulse at the top, and you have a slower pulse as you move down the rows. What you're looking at is desynchronization of beta band activity. Okay, and the important thing to notice is that we get desynchronization following every beat. That's not so surprising. Like, there's an event, the brain should respond to it somehow. It happens to be a desynchronization of activity. What's kind of remarkable is that the movement, the trajectory towards synchronization is timed to the beat. So this is not just the brain reflexively responding to an input. It's locked into this input. So what we would say is that the endogenous oscillators of the brain have attuned themselves to this external oscillator, which is the music. There's also evidence, and I would say a biological predisposition for vocal and facial mimicry. I don't think singing is unique here, but I want to clarify that this, in the same way that we get facial mimicry in response to affective displays, we also get it in response to song. So we've seen this at the peripheral level, we've seen it at the neural level as well. So this is old work, and I think I've been talking about singing for a while, and I haven't sang, and I haven't put up any singing, so this will be a good interlude. So in this paradigm, what we did is we presented the same song performed by a performer with happy affect or sad affect. And what we did is record from the facial muscles of people observing this song. And what we're looking for is this automatic mimicry of emotion.
Autumn leaves are
While in
turning
a conference, to hear
red.
the caller count, press *2.
Yeah, that was a little control in the
Press
experiment.
star
We had some of our participants call in and dial 1, 2.
To access listen only
I have no
mode,
control over
press
this. This
To
will
mute or
end.
unmute your phone, press *6.
Can you imagine
To
being
set
the
entry and
sound
exit
booth?
tones,
Being
press
wired up?
*8. To report an audio issue by sending a 60-second
All right, so
recording
here's
for
the
analysis,
complimentary
press
song. That's
*0.
sad.
Autumn leaves are turning red.
Okay, and here is activity in the zygomaticus muscle, the large muscle group that pulls up the corners of the lips. And you can see that when people are observing happy song, there's much more zygomaticus activity. When they're observing sad song, there's much less. Okay, so singing is a dynamic stimulus. Most of the work in vocal facial, I should say in facial mimicry has involved static displays. There's only a couple of studies that have looked at dynamic stimuli. In the few that we've done, this is what we see. So in fact, there's a little bit of evidence to suggest that the mimicry you get with a dynamic stimulus is stronger than the mimicry you get with a static stimulus. So I'm dancing around here, but what I'm trying to do is provide the framework for how we can use, again, just to remind you, I'm trying to provide the framework for how we can use singing therapeutically. So I'm cheating a little bit. Here I'm showing you some data not from a singing study, but a music study. We could have made it singing. It would have been complicated to do. I think the results would have turned out the same. We used this interesting social psychology paradigm here called the minimal groups paradigm. And no, I take that back. So what we did here, like I think that it'll be a bit complicated to explain it from that perspective. So what we did here is we took a group of kids who were in a camp, and we basically hijacked the YMCA programming for a week, and we gave these kids singing programming, visual art programming, or the regular competitive games programming. We then did these prisoner dilemma activities with the children at the end of the week, and essentially this is used in social and economic experiments to look at the propensity to share with other people from your group. And this is one example. We've done this in different ways, but it seems that singing promotes cooperation more so than do other art-based activities, and more so than competitive games. I really think it has something to do with the multiple levels of synchronization that I talked about earlier. It's not to say, of course, that the kids that spent a week making visual art had no gain, and there's no benefit to those kinds of activities. We're simply not tracking them in this paradigm. You know, you can think about perspective taking when it comes to visual art, and competitive games obviously has a whole host of benefits. All right, so I'm going to skip over this because this would require me to dig into the minimal groups paradigm, but maybe I can briefly say that you can even transcend group boundaries when you use music as an intervention, and you get people making music jointly. So you get people that initially feel like they're from different groups. I'm young, you're old, or I'm old, you're young, whatever the social identity is. Once people start making music together, their sense of shared identity tends to increase. So they perceive themselves as more belonging to one group than they did before they started singing. So here's an application in Parkinson's disease. So Parkinson's disease presents some challenges for communication. It's not the primary concern. But we know that there are deficits in involuntary facial expression. And it's been referred to as the masked face syndrome. So you can see a young and old, expressive and less expressive picture of Michael J. Fox, just to remind you of what this looks like. And similarly, what we have is this phenomenon of low speech and speech with very little intonation in Parkinson's patients. So what I'm going to do is characterize the deficit in facial mimicry in Parkinson's disease, and then talk about how singing might be used to mitigate that deficit, both at an individual level and then at a group level. So the first thing we wanted to do was to document whether or not there was a deficit in facial mimicry in Parkinson's disease. It seemed to us that there should be, since it's there's a motor deficit, there's this massive cell death in the substantia nigra, this should affect these kinds of involuntary mimicry responses. And when we looked at the literature, we saw that there was this growing evidence base that there's an emotion recognition deficit in Parkinson's disease. So if you think that mimicry is part of emotion understanding, as I do, I don't think it's the only way we understand other people's emotions, but it's an important route. I think it allows for automatic or rapid identification of emotions, albeit less accurate than the kinds of identifications you can have using other mechanisms. That was a long-winded sentence, but so we thought that there should be a deficit, and we wanted to document it before we started to intervene. So we recruited 27 Parkinson's patients, 28 age-matched controls, and we presented them with these kinds of stimuli. This is a large database of emotional song and emotional speech that's been validated. This was done with former postdoc Stephen Livingstone. So I'll show you what these stimuli look like. So we have audio. Dan, can I turn up the audio?
Knocking at the door.
There we go. I did it. Okay.
Dogs are sitting by the door. Dogs are sitting by the door!
Kids are talking by the door. Okay, so some of these are extreme, like the last two, and some of them are more subtle, and that's intentional. So we have low intensity, moderate intensity, and high intensity stimuli for this range of emotions, both in speech and song. And this allows us to probe emotion deficits in different populations, and here we're looking at it in Parkinson's. And the area that I want to focus on is the zygomatic response to happy displays of emotion. So remember the song stimuli I showed you earlier, we get a very robust smiling response when people are observing happy song. We see that again here when we look at the age-matched neurotypical controls. So we present happy, they get a very robust response, and we really get almost no response in the Parkinson's patient. So it's not surprising. We also see that the response is delayed, so it takes more time for them to have a change from baseline. So you look at the Parkinson's patients in the solid blue line below. In order to get a change from baseline, we need something like 2.5 seconds of exposure to this stimulus before we have evidence of mimicry. If you're relying on this automatic mimicry response or this embodied response to understand emotion, even in part, you can see that this really presents an impairment. Okay? And the way I think about this is that you can understand other people's emotions through other mechanisms, and those have been well explicated. It's beyond the focus of this talk. But a lot of the rapid exchange of information, the social dynamics of information and communication really depends, I think, on this embodied communication. And if it's taking you 2.5 seconds to do this, that aspect of communication is shut down. That's my thinking. So we also see that there's a relationship between the time it takes people to make a response and the strength of the zygomaticus response. So those that have a less strong zygomaticus response take more time to make an emotional judgment. Okay, so that's characterizing the impairment in Parkinson's disease. There have been 2 other reports, not from my group, corroborating this finding since this was published. So I mentioned that what we had in mind at the start is using singing as some sort of intervention to combat the impairment that we suspected likely existed in Parkinson's disease. So we've done that. This work is not out, but it's been with us. Some of you have probably seen me present this data already. For others, it will be new. So we took 26 Parkinson's patients. 13 of them were in a treatment group. 13 of them were in a control group. The difference between the treatment group and the control group is that the treatment group spends 13 weeks singing. The control group spends 13 weeks observing singing and making emotional judgments about that song. So it's the same stimuli they're working with, except one group is active and the other group is more passive, making these cognitive judgments. And we assess things at baseline, post-training, and 2 months follow-up. Here's what the therapy looked like, and it's using singing as a harness to support this automatic imitation. Theoretically, what we think could be happening is that because you can entrain the motor cortex through a regular pulse, which exists in song, then we have opportunity to facilitate this automatic motor response. So in the absence of a natural oscillator in the substantia nigra, maybe you can have this other one through this auditory motor connection. And through the process of mimicry, we can practice these emotional responses and maybe exercise some of these networks that have gone dormant since the onset of the disease. So there are many connections there, and by no means do we, to foreshadow there's some positive results. Who knows if the positive results are based on that causal explanation, but that's what we think is going on. So here's the therapy. He's looking at a screen and he's going to imitate this song.
Dogs are sitting by the door. Kids are talking by the door. Dogs are sitting by the door.
Okay, so I hope you can see that his voice is stronger. There's more facial movement. I think he's more expressive by the end of 13 weeks. And the therapy basically involved going from primarily singing at the start to primarily speech at the end. Okay, so we're not interested in training musical stars, or we're interested in helping people communicate. So this is the treatment in dark blue and control group in light blue. So there's a difference at 13 weeks. That difference is not significant at week 1, and it's there at 2 months. So this is interesting. There's many possibilities for why we might have obtained this result, but it's promising. It seemed to us that it might be possible to get similar results in a more efficient way by having people sing as groups. And so that caused us to start recruiting for what was initially called the Parkinson's Choir. That group has been singing for a few years now, and we have been collecting data on them. The data is a little noisier than the data we have from that controlled study, but it's also promising. So we see some recovery of the automatic mimicry. That data analysis is still in process, but that's the way it looks at the moment. It's interesting, the social evolution of this choir has moved very quickly, although the research has been kind of puttering along. The group has grown, and there are chapters in other cities now, in Hamilton, in Winnipeg, and it's now a nonprofit, and it now goes by the name Singing with Parkinson's, and you can find out a little bit about the group there at the bottom. They've been embraced by the Canadian Opera Company in Toronto, and they get to rehearse at the Four Seasons, which is quite a nice venue for them to work in. Okay, so jumping around again, we're moving now from Parkinson's disease to developmental communication disorders. So what we've been interested in and what we've started to do is see whether or not this singing mimicry paradigm could be used to support deficits in emotional understanding in other populations. So, for example, children with speech-language impairment, children with, who are on the autism spectrum. There are different reasons for communication deficits in those populations, and they're very different from the Parkinson's deficit, but they all seem to share some difficulty with reading emotions in others. And it may be the case that simply practicing this emotional mimicry using the tight coupling that song allows for may facilitate this ability. That's our thinking. So we've developed a game for this. This is a little promo video for what the game looks like.
Welcome to Big Break the Acting Game. I'm Bobby, and I own this studio where we make movies. We have a huge variety of genres with different directors ready to help you act and learn emotions. You'll be acting out for us and any points all along the way.
Pay attention to the actors and how they act out each line, because when you're ready, it'll be your turn to record the same line.
When you're all done a level, you can see your movie. You can choose to save the movie to your photo album or delete it.
Based on research conducted in the Smart Lab at Ryerson University, this game utilizes research-supported methods of emotional mimicry in conjunction with a sophisticated algorithm for expression analysis to guide kids in their development of social communication skills. Lots of kids can benefit from practice identifying and expressing emotion, especially kids on the autism spectrum, or those with attention or sensory processing deficits. Also great for brushing up on your acting skills.
Are you ready to make a movie? This is your big break.
Okay, so as the little promo video suggests, there's video-based analysis and acoustic analysis of what's going on. It's fairly primitive, I'll be honest, it really could be refined, but it allows us to gamify this whole process, so we can give kids points based on how well they imitate the emotional song or the emotional speech fragment. And as they do that, they unlock new studios, and that can be encouraging. We are on the, currently this game exists in the App Store. It's a nominal fee. We have been working to make it free, and we're just about there in terms of our development. I think it sells for $6 right now, and we've been working on how to make it free and support our development costs at the same time, and we think we've got a way to do that. So we've had some help from TELUS in that as well.
Welcome to Big Break.
It's doubling up. So this is what we've seen in our first study with this with children on the autism spectrum. So we've seen improvements in emotion understanding in an imitation group as compared to an observation group. Imitation in purple, observation in yellow. And we've seen improvements in social responsiveness, which is a measure that's sometimes used with children on the spectrum that reflects how well they're responding to parents and caregivers. Okay. So I mentioned that the unique thing about singing and music is that we have periodicity at the short and long time scales, and music provides us an opportunity. It's a kind of super stimulus to train these periodic elements of communication. By and large, I've been talking about the long time scale, the stuff that's related to beat and entrainment. Now I'm going to talk a little bit about the short time scale. So how can we use singing or music to train pitch perception in the service of basic communication? So we looked at children with cochlear implants. Children with cochlear implants have really difficulty with pitch perception because of the technology. There are some limitations, some engineering constraints that are not going to be solved within the near term. And often children will also present with social difficulties in school, and we know that they have difficulty with emotion understanding. So what we were wondering in this project is whether we, by training pitch perception skills through singing and music, whether we could support emotion understanding in this population. So we provided kids with singing and piano instruction for 6 months in this study. What you're looking at is their music ability. I'm not going to, on different dimensions that I won't unpack here. You're looking at pre, mid, and post training. And there is, of course, improvement at the end of 6 months. If there wasn't, this would be a grand waste of time because we spent 6 months training music. There is a difficulty, but we should be able to train music, and we were able to do it. But the really interesting thing is what happens to emotion understanding. That was our intention. And we see that the music training also led to improvements in speech emotion understanding, especially when you're looking at just audio, emotion presented by audio alone. So by the end of 6 months, we see that the group that was involved in singing and music outperformed our control group that was engaged in art, again, in this case. So we think what's going on here, again, is that the pitch perception that's necessary to decode intonation patterns and emotion are improved, and this is helping their emotion understanding. So another group, this is the last group I'm talking about, another group that has pitch perception difficulties is all of us. All of us, as we age, our ability to track pitch perception drops off. So there's a technique, an electrophysiological technique that allows us to track the brainstem response to isolated pitches. It's an old technique. It's been used by audiologists for some time. I think it's about 50 years now. And what you see in this kind of recording is that you get cells in the brainstem that are firing at the rate of the pitch. So if you have a pitch at 120 hertz, you actually get cells firing 120 times a second, and you can record this at the scalp. How do we know this is really happening in the brainstem? Well, there have been some interesting animal work using single cell recording, and I think we're on pretty firm ground that this is a brainstem response. And what we see is that as people age, the fidelity of this tracking of the periodicity of the micro time scale drops off. This might contribute to some of the emotion deficits in speech understanding in older adults. And it might contribute to difficulty with speech perception in noise. So we've been running a choir for a few years with older adults with hearing loss to see whether or not we can support their ability to hear speech perception in noise. So if you haven't heard of speech perception in noise because you're not a speech person, it is what it sounds like. It's people speaking and it's noisy. It's like regular life. It's the number one reason older adults go ask their GP for a referral to an audiologist. The common complaint is, look, I hear just fine. I can hear the television set. I can hear the radio. I can hear my partner. It's when I'm at a party or I'm at a bus station or at a conference, I just don't know what's going on. I can't hear anything anymore. Your ability to do that does appear to be related to the strength of this brainstem response. So we have older adults in this singing training session where we really focus on fine pitch perception and vocal pitch matching. After 13 weeks, we see that their speech perception and noise improves, so lower is better here. So that's baseline as compared to after 13 weeks. We see that the strength of the brainstem response improves after this very short intervention, so 13 weeks, and the ability of the brainstem to track for cells to be firing as fast as we're using speech as a stimulus, I should say. We're training with singing, but we're using speech as a stimulus. The ability of the brain to track that speech stimulus improves. And I'm not showing that data, but our ability to discriminate pitch as assessed by frequency difference Lyman's also improves. So I think that's quite promising, and we're expanding that work. We're now trying to recruit a new choir composed of people who have hearing loss who wear hearing aids, because they also have problems with speech perception. The hearing aid, again, there seems to be some engineering limits. There are all these algorithms for minimizing the noise, but speech perception and noise continues to be a complaint. All right, to summarize, singing improves a bunch of automatic processes that are relevant for communication. It improves periodicity tracking, and I'm referring to pitch as well as rhythm. It improves, there's some evidence that it improves spontaneous mimicry that I presented, and it improves rapid emotion understanding. So all of these things support communication. It allows us to explicitly label an emotion. It may support pragmatics, so turn-taking in communication. If that rhythmic element is trained, that might support that aspect of communication. It can support speech and noise. And then group singing might also support various aspects of health and well-being that are beyond communication, but that service communication nonetheless. So if I start to sing and I start to feel better about myself as a Parkinson's patient, then my identification as someone with Parkinson's goes from something negative to something positive. We have a new grant that we hope to start in the spring that's going to track this kind of phenomenon in different populations. So social identity and self-esteem. I think that's an important piece of the puzzle, because it's this social stuff that keeps people coming to choir week after week. I think you can get those gains in the lab-based studies that I showed you earlier, but you really have to push people, you have to work hard. I don't know how realistic it is in terms of an intervention. I think choir, if you can get similar benefits through choir, this is where we need to go. So here are all the group singing outcomes. I really don't know how to link them together at the moment. They just all live in some kind of orbit around communication, health, and well-being. But starting with pitch processes, these things, singing in a group, I think can support pitch processing, rhythm processing, emotion processing. Eventually, when you do this and you feel good about yourself, this might support mood, might support your self-esteem, and have positive effects on your social identity. Thank you for your attention. Questions, please. Yes.
That was a great talk, thanks. What jumped into my mind was when you have groups of people that are singing together, has anyone tried like online having someone at home participating with that as well? Any potential for that?
I would, you know, that model I know is being used with the Dancing with Parkinson's. They're using some sophisticated technology to make that happen. I haven't seen that in a therapeutic context with singing. I think it would be possible. Yeah, I mean, that would expand the scope of impact, bringing in people from rural communities, for example. Is that what you're thinking? Or?
Yeah, or people who just can't travel to a central location. Right?
Yeah.
Like a lot of people just have trouble getting out.
Yeah, I think that some of this could be done independent of the group for folks that are really motivated. As I said, I think the social benefits are super important. Yeah, So one of the things that I didn't mention in our singing training for speech and noise, is that we do have online homework exercises that they do individually. Getting it to work, getting the telephony to work, or whatever the medium is, for group singing, I think is a technological challenge, but worth exploring.
The singing-based intervention for patients with Parkinson's
Yes.
disease, you mentioned that was 13 weeks.
Yeah.
How long, the duration of each session was how long? An hour? Or?
It's so it's a 2-hour session, and they also do homework. So they're expected to sing for at least 2 hours a week. So, but each session, each in-lab session was just once a week, was a 2-hour session. And the choir is sort of the same thing. So that I'm referring to the lab-based therapy, but the choir meets for 2 hours a week. They sing for about an hour and a half of it. Half an hour is socializing, tea and biscuits at the end.
And the patients in that treatment protocol, were they at all different stages of diagnosis with Parkinson's?
We tried to recruit from stage 1 and 2. There were some people beyond stage 2. We don't have enough power to really tease that apart. I don't, and yeah, I can't really make any. But primarily they're in stage 2.
And just to follow up, technical question.
Yeah.
So when they improve, like you showed us,
Yeah.
the man who improved there, did the timing improve as well, or just you know how it took longer in your initial slides before the intervention?
We didn't look at that. Yeah, and yeah. So you mean both behavioral and the facial electromyography? Yeah, maybe that would be interesting to explore. Yeah, the data still exists, so it's possible.
So, Frank, fantastic talk, thank you. And, very fitting to the communications team at Toronto Rehab. Yay.
We talk all the time, by the way.
Exactly.
You know?
Most of the outcome measures that you showed are perception or recognition or understanding type of measures. Are there any plans to include production type of measures?
Oh, we have production measures, and none of that is published. So we're sitting on it. That kind of work other groups have published. So there is a literature on Parkinson's and range, FO range, and strength of like the loudest note you can sing gets longer. Articulation in the rainbow passage improves, and we have those measures in our data sets as well. That we're planning to publish, but there's nothing so novel there. I think the novel thing in what we're doing is tapping into the emotional aspects of communication, and that's what we've emphasized in our training protocols. And I think it's what makes our choirs a little different from other Parkinson's choirs that exist. If you're interested in Parkinson's choirs, I think this thing still exists online. Our parkinsonschoir.com has a world map. No, I shouldn't be advertising this because this is down. We've had a world map that has all the Parkinson's choirs around the world. There are a lot of them. This is not that novel a thing to be doing. It's the emotion piece that's novel. There are aphasia choirs. There are lung disease choirs, there are Alzheimer's choirs, and the grant that we hope to engage in starting in the spring will track the social outcomes in all of those choirs.
It's interesting that I think you've explicated the possible underlying mechanisms better than what we have in speech, for instance. But in aphasia, it has been documented that people will speak, even people with aphasia as well as so-called normals, in different kinds of syntax following the model, so we think of it as priming in speech production.
Yeah.
Following, just the model of something that they are hearing in somebody else's speech.
Yeah.
And you get that even in people who have a great deal of difficulty producing speech.
Right.
And it can be complex syntax as well.
I'm sorry, but don't we all mirror syntax, or this is something unique to aphasia?
No, we do all,
Yeah. Yeah.
and we can, but you might question whether or not you can get it in aphasia,
Oh,
right?
and it happens.
And it does happen.
Yeah. That's
So-
interesting. So that basic mechanism of mapping.
Of maybe things that when you talk about synchronization, but
Yeah.
maybe, it's some other
Yeah.
type of
Yeah,
synchronization.
so maybe that multisensory mapping, I'm not just gonna say auditory motor, the
Right.
multisensory mapping
Right.
is intact, that allows for this kind of automatic imitation, but there are motor deficits or other deficits that lead to the aphasia symptoms.
Yeah.
Yeah.
Is there anything that's looking at whether if you have facial paralysis at all, that makes emotional processing harder because you aren't able to have the mimicry and response?
There is some data I can think of that's relevant there. So, I know that if we artificially create paralysis, we can get an emotion understanding deficit. So you can do this by having someone gingerly hold a chopstick in their lips, between their lips without closing their lips, and clamping down on the chopstick with the teeth. That seems to interfere with the mimicry response. People have characterized it as a kind of facial muscle noise. It's like this tonic activity that doesn't relate to the stimulus. And you do see a drop in emotion understanding. There's some fascinating work with people who have received Botox, looking looking at emotion recognition prior to the Botox injection and after, and again you see a drop. As for different neurological or peripheral physiological impairments that affect that lead to facial paralysis, I imagine there must be something, but nothing comes to mind. Yeah. But it would stand to reason. And it's not that this is just to reinforce. I don't think. I think I'm in the minority in thinking that the embodied response is very important. Like, I think people recognize it, but it's if you look at the emotion recognition literature, it tends to be people tend to focus on what are the features, what are people looking at, what are people listening to, not this process of mimicry, and somehow that informs understanding. So there are clearly other mechanisms for understanding emotion, but I think the rapid communication of emotion depends on this embodied response.